Hello friends, welcome. Good afternoon all and welcome to our today's webinar on building custom models with TensorFlow. I am Dhanashree and today we will journey how to create a custom based model using TensorFlow frameworks. So here, this is a custom based architecture, how we can prepare these 4 steps together. How we can have a data preparation, model definition, training a model, and then finally a model evaluation. Along with that, we will do a deployment part. Okay, we'll understand how we can deploy this particular thing. So here, first we are having a data preparation. Within data preparation, we are having start with the raw data. Raw data means either we are having a raw data in a form of images, in a form of text, in a form of sensor logs or tables, whatever the data is. Okay, we will emphasize that this data is often inconsistent or noisy one. Okay, then we will have a data cleaning part. Within our data cleaning part, we'll explain removing duplicates, handling missing values, correcting errors, stresses, and importance of consistency. Okay, normalizations and all these things. Then we are having a data transformation, which will work generally on normalizing or standardizing the features. For example, for images, scaling the pixel values, for text tokenization, for tabular data, we are having encoder categories, and so on and so forth. And when it comes to data splitting, we'll split the data into training, validation, and test data set. We'll ensure each subset is representative. And here we are having model definition. Before model definition, we'll have a transition phase, which will here, what will happen? Whenever we will collect the data from a client, we will do a data cleaning, data transformation, splitting the data. This will change the entire transition of this data with clean, transform and split data into training, validation and split. After this, we are having a model definition. We'll define our model. So, firstly, here, choose a model type. Which model we want to choose? Which model we want to choose? So, discuss the decision criteria. For example, if it consists of image related task or a vision related task, we'll go for convolution networks. We can go for even deeper models like object detection, image classifications, okay, image segmentation, and so on and so forth. So when it comes to sequential data or a textual data, we'll go for recurrent or a transformer architecture. When it comes to tabular data or a tabular task, we'll go for a dense networks and machine learning models. Okay. So here, after this, we are having a use Keras API or low level API. Here, what it will do, it will describe the trade-off, high-level ease and the rapid prototyping versus low-level flexibility. Okay, so here, first what we are doing, we are adding or we are defining our model architecture. Once our model architecture is defined, we will narrate our building blocks. We will have our input layers. We will do a core transformation. For example, if it is an image data, we'll go for convolution and we will go for multiple layers. Convolution, inside that we are having activation function, pooling layer, dense layer, and finally our output layers likewise. So we can do our custom training also. Like we can have our custom models or custom layers we can add, or we can subtract some layer depending upon our whatever we want, because this model we are training from a scratch. If we want to apply a transfer learning model, okay, transfer learning is nothing but a pre-trained model. Okay, we are using a pre-trained model and we are using same as is. That is called as transfer learning. So here in the transfer learning also there are two things. Firstly, freezing a pre-trained model. If we want to freeze a pre-trained model, okay, then we will use this approach wherein all the layers are freezed. Okay, we are using a we are using a pre-trained model and directly training this model on on our business problem. When it comes to training on the network, for example, if we want to add some layers within the pre-trained model, this is when we'll do a fine-tuning part. Fine-tuning we are doing. Okay, then after this, obviously, after training our model, we will do a yes or no, means either we want to use a pre-trained model or not. Likewise. And then we are going to train the model. After training the model, we will have our loss function or a cost function. Along with that, what we want eventually, we want to increase our accuracy and we want to reduce this losses. So for that, for increasing the accuracy, we are having our optimization techniques. So we'll apply some optimizers and optimization techniques for increasing the accuracy. So here we will explain choosing a suitable loss function for the task and selecting the optimizers that will balance the conversion speed and the stability of this model. So here eventually our model will be fully specified. Our model layers will be fully specified. Either we are training our model from the scratch or either we are using our pre-trained model, whatever. So we are training our model to either of the way, like either training from the scratch or either training from the custom trained predefined models. Okay. So after training our model, we will go for a actual training process. While defining our model, we will go for a training process. So here in the training process, we will start with the start training loop. So here we will introduce the concepts of epochs and iterative weight updates. Okay, weight updates will go when we are applying a back propagation. Updation of the weights will happen. Okay, so after this, we will use a gradient tape for custom training models. If we want to, suppose here also there are two things, yes or no. If yes means it will describe the performing per batch forward and backward passes by handling the class, which will enable the dynamic loss adjustment. Along with that, we will have a multi-optimizer schemes. Then, if we will say no, then what will do? It will describe the simplicity of the built-in training loop, which will handle what? Which will handle a batching, shuffling, matrix, all these things will be handled here. So here we are having a training with Keras fit. Here we are having all these optimizers and other things. Okay. Then we are having our monitor metrics and losses, which will do what? Which will stress the importance of watching the accuracy, loss curves, or a custom metrics in real time to detect overfitting or underfitting of this model. Okay. Then we can use it for debugging and profile models. We will highlight the tools for catching numerical instabilities. We will have a shape mismatches and performance bottleneck. After this, we are having a save checkpoints, which will explain how periodic checkpointing safeguards and allows the mid-training rollbacks. Then after this, we are having our evaluation matrix. Once our training is done, once we are training our epochs, okay, checkpointing will be saved. We will save the checkpointing part. Okay, whatever the rapid change in the accuracy or losses, if there is certain hype in the accuracy or certain loss in the accuracy, we will check the highest accuracy, top 5 accuracy likewise. Okay, every time it will do a checkpointing and save the results. After this, we are having our evaluation and deployment phase. Within our evaluation and deployment, we are having evaluate model on a validate data set or validation data set. Since we have trained our model into a training data, we will evaluate our model into a validation data set. While running your model, what it will do, it will held out the data and interpreting the metrics such as accuracy, precision, recall, and so on and so forth. Then we are having a performance satisfactory. Here also we will have yes or no. Yes means it will export and save the result. No means it will tune and it will do a hyperparameter tuning. Okay, so within our hyperparameter tuning, we can do our learning rate, we can adjust with the data augmentation techniques, regularization techniques, and so on and so forth. Finally, retraining the models, multiple things we can do here. Once we want to save and export this particular model, whatever the performance it is giving, we will integrate this with the TensorFlow extended and save this particular model. Okay, we will outline the packaging, the pipeline into a components like ingestion, transformation, training, validation, serving, and finally to saving this particular model. Then after this, we will deploy this model for the interference purpose. Once the training and the validation accuracies are closer to each other, we can save this particular model. Once we have saved this particular model, we can use it for deploying. We can deploy the model on mobile devices, edge frameworks, or browser-based runtimes. Multiple things we can do. Okay. So this is how we have understood how to train a custom models using TensorFlow. So here we have understood the data might be of different things. Okay. The data might be unstructured or a structured. If it is unstructured, if it is an image related data, how to deal with it. What models we can use. If it is related to textual data, what things we can do for cleaning, for transformation, for splitting the data, what are the approaches we can adopt. This is the first step. After this, we have understood about the model definition or how to define this particular model. Whether you are using this model from like a pre-trained model you are using, or you are custom or you are training this particular model from the scratch, whatever the purpose you are doing, you have to define the entire architecture of this model. Once the model architecture is defined, all the layers are defined, what we will do? We are going to train this model on a training data. Once we have trained this model on a training data, we will save this particular model. After this, we will evaluate this particular model on a validation data set. We will check whether this particular model, which is the training accuracy versus validation accuracy. If it is closer to each other, we will save this particular model and we can use it for deploying this particular model. Okay, so this is what we have understood from here. Now, there is one code also. Okay, so here we are using our TensorFlow frameworks. Okay, we are using TensorFlow frameworks. We are importing all the required libraries. We are importing Keras here and we are importing the layers, models and applications. We are taking the data set directly from the Keras. Okay, keras.dataset.10 Cipher10. Cipher10 is a publicly available dataset. If you will search in a Google Cipher10, you will get the whole understanding. Okay, you will get to know about what is this dataset, what are the different features in this dataset. So this dataset is directly present in this Keras library. So we are calling this dataset from this and we are importing and downloading this dataset. Then what we are doing, we are splitting this dataset. After splitting the dataset, we are doing some data transformation techniques. Okay, we are doing a scaling to this data. We are doing data augmentation techniques. All these things we can do. Here I haven't done. Here I have only splitted the data into training, validation and test. Okay, but what other things we can do? We can even do a data augmentation. We can even apply some scaling techniques. Okay, resizing of this particular all the images. If it is an image data, Cipher10 is an image data. Okay, so if it is an image data, we can resize all the images to one size. This also we can do here. Then now what we are doing, we are defining this particular model. Okay, this is how we are defining this model. Okay, once we have defined this particular model, we are adding this, we are adding the hyperparameters here. We are adding the optimizers. Okay, what optimizer here we are taking? We are taking add-in and we are taking learning rate. Okay, learning rate as an optimizer. Then We are saving this particular model using a checkpointing. Once we have saved this particular model using checkpointing, after this, what we will do, we will going to run this particular. Here I have run only 2 epochs. This step we can add it above also, and we are just running 2 epochs here. We can run multiple epochs. We can run 10, 100, whatever the epoch size you want. After this, we are doing an evaluation and deployment part. So evaluation will do what? We have splitted our data set into training, validation, and training, validation, and test. So we have trained our model into training data set. And now what we are doing? We are testing our model on a testing data set or a test data set. Okay. So we have tested this model on a test data set. Once it is tested, once the accuracy of the training versus testing is same or closer to each other, we are going to save this particular model also. Then what we can do, we can use it for edge deployment, mobile-based deployment, multiple things we can do here. Okay, so this is what we have done here. I hope it is understood. So this is it from my side, guys. This is our QR code. This is our contact details. You can just call us. Okay, our salesperson will call you. Okay, you can, for inquiry, you can mail us also. Okay, you will get a call from our custom salesperson. Okay, thank you so much. We'll see you in the next lecture. Thank you for joining.